Welcome to PME channel, and now we will go through the types of modulation. Previously I have just made it to you that there are two kinds of modulation. One is continuous sinusoidal wave modulation. This is continuous sinusoidal wave modulation. This is continuous sinusoidal wave modulation. Continuous sinusoidal wave modulation. And this was pulse modulation. Note it down. This is the analog signal. This signal is analog. I will just write analog signal. And this signal is digital. This signal is digital. Digital modulation you will study in engineering, but just for the sake of knowledge from competition point of view, particularly NEET or and JEE main point of view, you must understand these two types of modulation. One is continuous wave modulation and pulse modulation. Pulse modulation, note it down. This is digital modulation. And this is analog. This particular modulation is analog. And in analog modulation, we have got amplitude modulation. In amplitude modulation, note it down. I will just show you the diagram in my next lecture. In amplitude modulation, you just vary the amplitude of the wave. Amplitude of carrier wave, CW, you vary the amplitude of carrier wave with respect to the information signal. And second is angle modulation. In angle modulation, it is of two types. One is frequency modulation, other is phase modulation. In frequency modulation, you just vary the frequency. You vary the frequency of carrier wave is varied with respect to the information signal. In phase modulation, it is the phase of the carrier wave. Simple. In amplitude modulation, amplitude of the carrier wave is varied. In case of frequency modulation, frequency of the carrier wave is varied with respect to the information signal. In phase modulation, phase of the carrier wave is varied. Now, pulse modulation, PM. So there are two kinds in pulse modulation. One is analog modulation and digital modulation. In analog modulation, it is PAM, pulse amplitude modulation, pulse width modulation. And then in case of, you can say, digital modulation, we have got pulse code modulation and then delta modulation. This is pulse phase modulation, modulation. Pulse amplitude, A stands for amplitude, W stands for width, and this P stands for phase. One is pulse amplitude modulation, pulse width modulation, and then pulse phase modulation. So this very diagram, it tells us about, you can say, it tells us just about various kinds of modulation. One is continuous wave, it is of two types. Continuous wave means analog signal, amplitude modulation, angle modulation, angle modulation further divided into frequency modulation and phase modulation, pulse modulation, analog and digital analog further divided into PAM, pulse amplitude, PWM, pulse width modulation, pulse phase modulation, PPM, and then digital modulation here. This is the digital modulation. It is further divided into pulse code modulation and then delta modulation. And now I will focus on the types of modulation. I have outlined it first. We will just go through it one by one. And we have, in fact, had a glimpse of this part of the theory in this particular tree. Now, I will like to skip it quickly because we have got other very important issues to take up. One is carrier wave may be continuous or it may be discontinuous. Now, in case of continuous, we have got sinusoidal carrier wave, and then we have got amplitude modulation. Just see the left part, and then frequency modulation, and then phase modulation. So here we are just talking about this part, amplitude modulation, frequency modulation, and then phase modulation. In the next part, we have got pulse, carrier, wave. Types of modulation is PAM. This is pulse amplitude. You just focus on the tree which is available. Pulse amplitude and then pulse time and then pulse position. Another is pulse phase. And then pulse width modulation and pulse duration modulation, PDM. Now this pulse time modulation is further divided into pulse position modulation, pulse width, and then this pulse duration modulation. Then phase code modulation, PCM method is preferred. Now this is about PCM question was asked. That's why I'm going through this diagram. PCM is preferred in digital communication. While other methods are suitable for analog communication. In our very next part, we shall be going through a mathematical expression. Before going through a mathematical expression, I want to show you this diagram because I'm repeatedly talking about this amplitude modulation and frequency modulation. I just want to show the diagram so that before going into the mathematical work, you should be more and more familiar with this part. In this part, particularly, this is the pulse amplitude modulation. And in this part, kindly note it down, this is the carrier signal. Carrier signal is high frequency signal. This is information signal. This signal is information signal. It has got low frequency. This is a low frequency signal. Carrier wave or carrier signal. This has to carry this. High frequency signal, carrier signal has to carry information signal or modulating. Note the term. One is carrier signal, other is modulating signal or information signal in simple language. And both of them has to be mixed up. Note it down. This is the modulating signal. This is carrier signal or carrier wave. Now, we vary the amplitude of this carrier signal with respect to this. How you can clearly see here, the amplitude of information signal is rising. Same you can see. Now this wave has been changed into this. The amplitude is rising. The amplitude of the carrier wave is rising or carrier signal is rising as the amplitude of modulating signal increases, and now the amplitude, you can say displacement of now this wave rises. You can say in this case displacement rises. It here in modulated wave it is the amplitude that rises. In the next part displacement falls here. Displacement decreases. When displacement in information signal or modulating sine wave decreases, decrease in the amplitude of the wave takes place. And now, as the displacement of information signal increases, now here increase in amplitude takes place in case of the carrier wave. In this way, we vary the amplitude of the carrier wave with respect to this modulating signal. Next is frequency modulation. Here we have varied what? We have varied amplitude. And now this is frequency. You have to vary the frequency with respect to the displacement. Amplitude increases. Not amplitude, in this case displacement increases from here to here. You can see here frequency decreases. Waves are more and more wide, and when it has started decreasing, it has gone on the negative side. Here the frequency is very large in this part, and here frequency achieves its maximum. Now it goes on decreasing and it becomes minimum in this part, and then it again increases, becomes maximum. Now we are varying the frequency of the information signal, of the carrier wave. We are varying the frequency of the carrier wave with respect to the basic information signal. Now, what is important? We have got two kinds of modulation. One is frequency. We vary the frequency of the carrier wave. Previous was amplitude. We varied the amplitude of the carrier wave. Now, this diagram, which is very much akin to beats, this is amplitude modulation, diagram for amplitude modulation. This is diagram for frequency modulation. On the same line, there is phase angle modulation. This is phase angle modulation. Phase angle modulation, in this case, we vary the phase. Here, we vary the phase. Diagram is in front of you. You can go through. This is the carrier signal. Carrier signal is high frequency signal. Now its phase is to be varied. This is the modulating sine wave signal. And here, phase modulation signal. So we have just gone through the basics of types of modulation. And here, sinusoidal wave. How do we represent a sinusoidal wave? And I also want to take on this issue before finishing this lecture. And here, we have got a sinusoidal carrier wave. Sino means it's a sine curve. Here is the sine. This is the carrier wave. Note it down. This is the carrier wave. Carrier wave, AC, is the amplitude of carrier wave. AC is the amplitude. WC is the frequency of carrier wave. Phi is the phase difference. Now this is total is the phase. This is basically WT plus phi is the phase. Now CT. CT is the signal strength. Signal strength can be expressed in terms of current or voltage. So AC is amplitude of carrier wave. I have already indicated you. And next part, this is the frequency, angular frequency. No issue about even angular frequency. This is angular frequency of the carrier wave. And I can again write that expression in front of you, which is this CT. Signal was CT, time varying signal of carrier wave. AC is the amplitude of carrier wave, and then this sine of omega c, frequency of carrier wave, plus phi phase. Now, nu c is the frequency. It is in hertz. Note down that omega is angular frequency. Angular frequency, and this is nu c is just frequency. Phi is initial phase of the carrier. Initial phase of the carrier means when t is 0, then phase is phi. If t is here, then it will be sine phi. If t is 0 here, we shall be having at t is equal to 0, I will just write C0 is AC sine phi. Phi is the initial phase when the time t is 0. So what is important? We have got three variables in carrier wave. One is amplitude. If we vary amplitude, we get amplitude modulation. If we vary frequency, we get frequency modulation. If we vary phase, then we get the phase modulation. With these words, I finish this part of the lecture. In my next lecture, we will proceed ahead on the next topics of amplitude modulation. And this topic of amplitude modulation is again very important from all kinds of exams. This was also very important from all kinds of exams. Sometime question have been asked PAM. PAM is a digital modulation or analog. Now it's very much clear. PAM is digital modulation. And this is continuous modulation. So with these words I finish this lecture, and we will